Hello and welcome to Protecting with Engineering. My name's Hermione Cockburn. I am your host for this session, which is part of Protecting Our Planet Day 2024, or POP24 as we like to call it. And all day the POP team have been streaming the most incredible sessions from POP Mission HQ here at Dynamic Earth Science Centre in Edinburgh. Now this session, which is all about following a career in engineering. It might be the one you're tuning in specifically for, or you might have been with us for hours already. But either way, stay with us now, and I'm going to introduce you to three very different types of engineer. Now, all of them, I would say, are relatively near the start of their careers, but already the work that they are doing is having such an impact, providing insights, breakthroughs, practical solutions to what we need to do to protect our planet for the future. They're going to be explaining about what's inspired them, how they got from school, where you might be, into their jobs that they're doing now. And after we've heard from them, it's going to be over to you. We're going to leave time at the end for some questions. So if you've got questions for any of our panelists, be sure to pop them in the chat, and we will make sure that we get to them before the end of the session. The session is being recorded, so you can come back and re-watch this. It'll be up on the STEM Learning YouTube channel sometime before the end of the year, before Christmas. And if you're going to be posting anything on social media about your engagement with POP, make sure you tag us POP24. Now, just before we get to meet our engineers, I've got a little bit of a confession. I am not an engineer. I work in public engagement with science, which means that I work alongside scientists and experts, helping them explain and communicate the work that they're doing so that people of all backgrounds and all ages can appreciate the value of science and the relevance of science to them in their daily lives. Now, engineering, as I understand it, is all about applying science and making sure we're putting good science into the practical and technological solutions that we need to ensure that we live on our planet more efficiently or just better, really. That's what engineering is all about. In terms of a career destination, it's a really broad destination. So without further ado, we're going to meet the first engineer that we've got lined up for you. And I'm really pleased to introduce Sehar. Sehar Raza is a graduate engineer. She's working in offshore transmission in the Energy Networks Department with WSP in the UK. So Sehar, I think we can come to you now, and you can tell us all about the work that you do. Hi there.
Right, thanks for introducing me. So I'm Sehar. I'm an engineer working to reduce carbon emissions in the electricity grid system, which is used to bring electricity to you in your homes. I'll explain what I do in a bit more detail, but first I'm going to take you through the key experiences in school and university that led me to this job. So at school, I found it really hard to picture a specific future career, but what I did know was I wanted to make a difference and be in a career that I could be really proud of. I also knew that I wanted to actually enjoy what I'm doing. And when I got to my last years of school, I found myself really enjoying maths and physics. I didn't at the start, but I more was into the more artsy projects near the beginning, but just my last years of school, I just found that's what I was most interested in. It wasn't until I learned about engineering where I could imagine a career that met both my passions and interests. I was introduced to engineering in my last 2 years of school, so quite late on, through talks like this one and through engineering programmes. I attended Scottish-based school the summer before I started applying to uni, and this was a great experience where I got to live at university for a week, take part in activities from different engineering departments, talk to students about why they were studying engineering, and hear all about exciting careers engineers could go into from people working at NASA. But picking one type of engineering to study was a really tough decision, as they all looked interesting and could lead to exciting careers. That's why I picked electrical and mechanical engineering, where I took all sorts of classes learning about renewable energy, robotics, spaceflight systems, nuclear power. And I got to learn about all these for different methods like lectures, practical labs, programming labs, and computers. By studying EME, I could picture a number of exciting career paths, a number of very exciting but different career paths. But joining the Engineers Without Borders Society at uni reminded me of why I picked engineering in the first place. And that taught me about the role engineers can play in solving global challenges like tackling climate change, ensuring everyone has access to clean energy, and achieving a sustainable future. This influenced the classes I took in my last 2 years of uni, learning about how clean energy is produced and delivered to our homes. And it also helped me to decide what to do for my final year project, where I really enjoyed creating a game board that taught people of all ages and backgrounds about renewable energy systems within different communities. At the end of uni, I also volunteered at COP26, or Conference of the Parties, which is where world leaders come together to plan on how we can reduce greenhouse gas emissions in each country to fight climate change. This is where I learned about the difference engineers can make to help save and protect our planet, and this inspired me to apply for the job I have now. So I work as an engineer in interconnector projects. Interconnectors are basically large undersea power cables that connect countries, allowing electricity from renewable sources to be shared across the world. The UK currently has 9 interconnectors, so we can share electricity between Ireland, France, Belgium, the Netherlands, Denmark, and Norway, but the number of interconnector projects in planning and that are being built just keeps growing. I mean, WSP right now is involved in an interconnector project connecting the UK all the way to Morocco. Interconnectors are really useful in the fact that they help the UK to receive electricity from other countries at times of high electricity demands, so after school or work when everyone is back home, and also deliver electricity to another country when too much is being produced. So on windy days when we make too much electricity from wind turbines. Interconnectors help bring renewable energy from where it's being made, so from offshore wind farms far out into the sea, back to our homes. Renewable systems are based on weather conditions though, so they can be quite intermittent, but interconnectors can help ensure that we have electricity at all times by quickly sending large amounts of electricity to where it is needed. So since starting at WSP just over a year ago, I've worked in the Greenlink Interconnector project, which connects Ireland and Wales. Basically through a large power cable which is being laid in the picture shown in picture 2. This project is capable of powering like over 380,000 homes with clean energy, so it's really important in reducing carbon emissions and helping to tackle climate change. My team has worked on this project for over 6 years, and as a team we tend to get involved in projects throughout all stages, so from like the initial planning stages right through to testing and commissioning, which means that we get to meet and work with lots of different people, which is really exciting. And we also get to work like in our offices, but also on site. So I got to spend 3 weeks in Wales on our construction site, shown in the picture at the top. And I also got to spend 2 weeks training and witnessing tests in Germany. I guess the final point for me is like, yes, I'm really lucky to have finally found the perfect role for me, but I didn't figure this out until I was 24. And I think the key thing to figuring out what you want to do is to say yes to all the learning experiences and opportunities you can to find out what you're really interested and passionate about. That's me. Thank you for listening.
That's fabulous. Thank you so much. I could really get a sense of enjoyment about your job coming across there, Sehar. And I think that's so important, isn't it? To work on things that you enjoy. And as Sehar says, you might not work it out until you're 24. Now, I think we're going to move on to our next panellist now, who is Ross Sanders. And Ross is a marine robotics technologist working at Plymouth Marine Laboratory. So, Ross, let's come to you now and let's hear about how your career has shaped up.
Hello, thank you very much for the introduction. So my name is Ross Sanders, and this is how I became a marine robotics technologist at Plymouth Marine Laboratory, or the alternative title, if my slideshow works. Here we go. How I went from being on growing up on a small farm in Cornwall to driving an ROV around a data buoy in English Channel. So in terms of education, I've always been in engineering. I actually did a GCSE in electronics, which I was very fortunate to do at Liscard School and Comprehensive. And then when I was doing A-levels, I chose very kind of STEM subjects. So electronics, again, I was fortunate enough to do at Truro. I did physics, chemistry, and mathematics. I enjoyed all of them. I actually really enjoyed chemistry and could have been a chemical engineer if life had turned out differently. Then went on to do a degree at the University of West of England in electronic and electrical engineering. And I did a year in industry. So between my second and third years, I went off to work for a company called Offshore that make industrial measurement equipment as an electronic engineer. And that was incredibly useful to kind of work in a real environment with real deadlines, real equipment. That was so useful. So if you're looking at engineering courses, please consider a year in industry. My first job coming out of university was with the British Antarctic Survey. I was a wintering electronics engineer at Halley Research Station. So I was there for 18 months. So an Antarctic summer season where the sun doesn't set and it gets down to about -20. We were able to go and see the emperor penguins. We were near the world's largest emperor penguin colony. Do lots of field work, so going out on skidoos to measure how ice shelves are moving. And we were monitoring lots of different scientific aspects from space weather through to the atmosphere down to the ice itself. I then did an Antarctic winter, which is where the sun sets for 3 months of the year. And it got down to -50, and we saw the Aurora Australis, absolutely beautiful sight. And we were the only people around for about 500 kilometers. So the nearest people to us were on the International Space Station. It would have been Tim Cook at the time. I then went on to work for the British Antarctic Survey full-time as an electronics engineer. So this was based at the headquarters in Cambridge, where I did a lot of work automating instruments. The picture of me there with the orange overalls, that's a Dobson photospectrometer, which is the instrument that was used to find the hole in the ozone layer. So normally it's a very manual instrument that a technician has to operate. I automated it so it could work during periods where the station was unstaffed. I've also been able to do a lot of field work from aircraft and indeed walking out into the field, and also a lot of work on the British Antarctic Survey's vessels, such as the Sir David Attenborough, who I think we got to speak to earlier, and also the JCR. So this was a lot of oceanographic work, studying how the oceans are changing, and also a lot of atmospheric work, looking at greenhouse gases and how their effects on the climate are affecting everybody. I then went on to have a brief stint in the commercial offshore geotechnical equipment sector as a principal electronics engineer. I designed some systems for installing offshore wind turbines. This was a really large drill, which had an 8.5 meter diameter drill bit, absolutely ginormous. I designed the control system for that. Some launch and recovery systems for lowering equipment into the sea. These were to move away from hydraulics over water, so using electrification to provide for kind of greener solutions in a greener world, and some coring systems, again, for the offshore wind turbines, so that geologists can know what the sediment layers are like, so they can drill the correct foundations for offshore wind turbines. It's all really exciting. I'm applying all the stuff from university and even all the way back to GCSE in my day-to-day life. And I now work at Plymouth Marine Laboratory as a marine robotics technologist. So I'm responsible for providing automated solutions for marine science. So these can be our water sampling rosette. You can see me there smiling away on the back of our boat, the PML Quest, through to our data buoys, which we have in the English Channel south of Plymouth. These are collecting lots of data. We have a profiling CTD, so it's telling us all about the water column as part of our long-term data set, which goes back to 1988. Through to autonomous surface vehicles such as the Autonaut that you can see on the bottom left, which is a fully autonomous surface vehicle that we can send out on missions for up to 90 days at a time. And I get to play with all these toys, and it's great fun. So thank you, that's me.
Oh, thank you, Ross. Again, just like that fun element coming over in your job. Can I just ask you, Ross, a quick question before we move on? How did you get that first job in Antarctica? Because I imagine they're very sought after.
That's an excellent question. So they are certainly sought after. I think a few hundred people applied for my role. when I first got it. I was actually into climbing a lot at the time. And I think I was in my final year at university. We'd just come back from a climbing trip in Italy, and I was looking for a climbing magazine, and there was a full page advert for a field guide in Antarctica. And they had an amazing photo of like somebody doing ice climbing. It looked really cool. I went onto the British Antarctic Survey website to just see what the role involved. I was not qualified at all for it, but they had a role for an electronics engineer. I was in my final year at university and thought, I'm very nearly a qualified engineer. I'll apply and managed to get the job. So I think all my other experience doing climbing and lots of outdoor things, working on a farm and being very resilient,
Yeah,
definitely
yeah.
helped me.
Yeah.
And I got the job for a lifetime.
Oh, fabulous. That's a great story. Well, sit tight because we'll come back to you with lots more questions in a moment. But before we do, I'm going to introduce our final panellist, and that is Ben Winchester. And Ben is a postgraduate researcher. He's in the Department of Chemical Engineering and at the Grantham Institute at Imperial College London. Hello, Ben. Tell us about your career.
Hi there. Yeah, my name's Ben, postgraduate researcher, which I sort of think is code for PhD student. So I'm in the final year of my PhD in chemical engineering, and I'll get on to sort of what I do now and how I got there. So at school, I studied quite similar to everyone else, sort of very science focused A levels, maths, chemistry, and physics. And I didn't really know what I wanted to do afterwards. Unlike everyone else, I feel I came very late to the engineering party. Um, so I went off to university and studied physics, which I just sort of chose based on what I was most interested in at the time. Um, and it was a really great degree, really great fun. I enjoyed lots of the sort of practical aspects, less practical than engineering, um, but it contained maybe more of the sort of theoretical stuff that I quite liked at the time. So more sort of the maths and sort of quantum mechanics and particle physics, which I found really interesting. And I got to the end of my 4 years and again didn't really know what I was going to do next. Um, I hadn't really got anything planned or anything lined up. And so I did sort of what a lot of people might do, which is sort of a gap year. I took some time out to travel and set off on a sort of journey around the world by train. Started in the UK, uh, headed around sort of up through Russia, which was all really, really great fun. Saw lots of amazing sights, lots of great people. Everywhere we went on this trip was what really sort of struck me about it was the amount of air pollution and sort of smog and smoke. And Russia was really great, but being so close to the sea, there was a lot of pollution that was car fumes mixing with sea air. And it was really quite smoggy and difficult to breathe. It was a similar story as I sort of traveled around further east towards China. Again, it was all really beautiful, really stunning. But the pictures aren't quite like what you find on Google. A lot of sort of um, air pollution and a lot of dust. And similar to Kathmandu, which was a really amazing place to visit. Um, but again, there was so much pollution that you couldn't see the sort of mountains that were maybe only 3 or 4 miles away because the air was so thick with smog. So it sort of really inspired me to do something climate related. I didn't really know what it was going to be, but I wanted to do something where the work I did on the day to day, in some small way, had an impact on how we treat the planet. I tried to find opportunities in environmental work, and sort of nothing really happened. So I took a turn into engineering, maybe not through an engineering degree, but via the sort of back door, I like to think, through software engineering. So I worked for a year and a half on for a company called Cisco, which sort of they work on these um, large big computers that we don't really see, but they sit between whenever you use a mobile phone or computer or anything to access a website. It goes maybe from your phone to your phone carrier 3 or EE or someone, and then through these really big computers that they built that sit in warehouses somewhere before it reaches the website and eventually Spotify or whatever video of a cat we're trying to watch at the time. And it was really great fun, and it took the stuff I'd learned at university and a lot of the theoretical bits around science that were part of my physics degree and applied it um, to real things. Software maybe isn't real, but the computers were real. So I like to think there was some practical aspect to what was going on. Ultimately, though, I felt I still wanted to do something climate related, something to do with the planet. And so I was looking around for opportunities to get back into environmental research or to start something more eco-friendly. And so I then applied and got a PhD at Imperial College London. In chemical engineering is the department I'm in, but it's sort of, I like to think of it as energy systems engineering. And a lot of the questions that I try and answer and the things I do now look at solar panels, which we see a lot of in the UK on people's roofs, and we see a lot in fields. And that's really great. And it's really important because we have to reduce our impact on the environment and reduce our carbon footprint. But when we look at maps around the world of where people don't have access to power and where people don't have access to drinking water, and there are lots of other challenges, agriculture and education and healthcare, a lot of the maps all look quite similar in terms of the places in the world that do have access to power and the places that don't have access to power. And so a lot of the work I do looks at solar panels and whether we can use them to try and answer questions and help people in these, this is sort of sub-Saharan Africa, pictured here, Africa that's sort of south of the Sahara. And a lot of the research I do is how we can best apply these solar panels to meet some of the challenges around drinking water and around energy. So I'm my final year, and I sort of have done some practical engineering, at least. A lot of what I do is theoretical, but these are the solar panels that I've installed on my narrowboat that I live on, which is it's a small impact, but it was still a fun sort of system to get my hands on. And as so much of what I do is theory, it's nice to sort of see some practical things being built, get my hands sort of dirty that way. Yeah, that's sort of my journey then.
Oh, thank you so much. I love the fact that that's your work kind of crossing over to your very cool looking houseboat. And Ben, I just want to go back to that motivation that you had to move from what was probably a very well-paid job in industry and then to go back into research and academia and go for your PhD. Talk us through that moment in your career.
Yeah, it definitely was a significant pay cut and a sort of transition for something that was a very stable job where there's a nice career progression as you go through to something where it's a lot more unpredictable and year by year you don't know what's going to be coming up next. So it definitely was a sort of leap into the unknown, and it sort of still is a leap, a journey in the unknown. But I felt that the climate emergency and sort of climate change and our impact on the planet is so pressing that I felt that it was worth taking the risk. It was worth going into something. And I was just looking around sort of everywhere that had PhD opportunities in research. And it was sort of just by chance, really, that I found this one. But I'm really glad I did it.
Yeah. Thank you very much. Well, now we've got our three panellists back with us. And remember, now is your opportunity. We've got 8 minutes. Put your questions into the chat and I will pass them on. We've actually got one question already come in from Sutton Grammar School, and this is to you, Ross. And the question is, what was the most challenging part of your trip or your work in Antarctica? And that's from a Year 7 student. So yeah, what was challenging about your time right down south on the ice?
Oh, that's a really good question. The most challenging part was definitely being so far away from my friends and family. So particularly during my winter, that was a year and a half away, about 12,000 miles away from everybody back at home, in a completely different, isolated environment. So I obviously missed like everybody's birthday. I know for certainly my mum's birthday, we were launching weather balloons every day. So I wrote on a happy birthday, mum, and sent her a nice photo of launching this weather balloon. But yeah, being a long way from everybody I loved.
Yeah, well, I chose a background here. This is a ship down in Antarctica. How was it being on ships? Because you spent some time working on board research vessels, is that right?
That's right. So I spent, I've been on about, I think 7 cruises in Antarctica. So on the British Antarctic Survey's old vessel, the James Clark Ross, and their newer one, the Sir David Attenborough. Both were very nice, and life on board a ship is quite monotonous. So you end up doing the same things every day. We'd get up, have breakfast, do lots of science. Whenever equipment broke down, I'd have to go and repair it. That was my role. I'd have meals at the same time, usually sit with the same people. And it was absolutely amazing. So we'd go through, say, Drake's Passage, where we had huge waves, like 20-meter waves. The ship would be bucking all over the place. You're sliding around, trying to sit at a desk, and you'd disappear to the other side of the room and come back again. And then when you get into the ice, it suddenly goes really calm, and it's just pristine white outside. And so you go outside to enjoy it, and it's freezing cold, as you would imagine.
Yeah, yeah.
So you go from wearing, say, a t-shirt or something inside, like the people on the SDA were earlier, you stand outside and it's suddenly minus 20 and freezing. And you can see penguins and seals and, if you're very lucky, whales coming out of the water. There's nothing like it. It's an amazing experience.
Right.
I can't recommend working in these kind of places enough.
Well, it's where engineering can take you. That's amazing. Sehar, I want to come to you next because your career seems so logical in the steps that you've taken, and now you're working on interconnectors. And it's not something that perhaps many people know that much about, but it just sounds so central to the way the world works, really, and how we need to kind of develop our energy systems. Why did you go into interconnectors? That's what I'm sort of quite intrigued about. It seems quite a specific niche area. What led you there?
Well, I guess after COP26, I knew that I wanted to work in the energy sector, work to reduce carbon emissions and work to help tackle climate change. But at university, my subjects were mainly based on renewable energy. I didn't really learn about interconnectors until my last year, and it was one lecture in one of my classes. And I was just really interested. I was really interested in learning about a new technology, a new way to bring energy to our homes. Yeah. And I just wanted to learn more. And the more I think I learn about interconnectors and how it's really just a growing industry, like the number of interconnectors that are currently going into planning and development is huge. Yeah. I think I was just excited to be in this kind of like new emerging industry. Yeah. But even then, I applied to WSP because it's a massive energy company, and I applied to a department and got put into this team with the idea knowing that I could move if I wanted to. I could move to a different energy team. I could explore different projects, but I ended up really liking the team I got put into, and I think I'll probably stay here for a while anyways.
Great. Well, there you go. Go to your lessons, go to your lectures, because you never know. There could be one that just really inspires you for your career. So that's a great story. We've got some more questions coming in on the chat now. So here we go. Ben, one for you. What are your further plans for your research career? Yeah, what's happening in the future, do you think, for you?
Yeah, ideally I've got a plan for next year, and other than that, the plan is to sort of keep going as I go. So next year, I'll still be looking at renewable energy and solar panels, and I'm going to sort of start shifting into this question of farming and solar and whether we can combine the two. In the UK, we have not a lot of land, and there's often a sort of competition, or at least people think there's a competition between whether we have solar panels on some land or whether we have a farm for agriculture. And governments are sort of variously including and excluding places you can and can't put solar panels. And so the plan is to go into research around what if we can combine these two things together, and maybe we can put solar panels on top and have some sheep grazing underneath, or maybe we have solar panels that are sort of in long lines and then you can still drive a combine harvester in between. Or maybe we're doing something really fancy like solar panels that go on top of a greenhouse and they let some of the light through to the strawberry plants underneath, and then some of the light gets taken away to power the water pumping, or maybe the sort of machinery that's being used to milk cows or chill the milk down.
Wow. Yeah, real exciting innovation really on the horizon, I think, by the sounds of things. Now we've got a really interesting question come in now, and I think you three are just sort of like amazing sort of standout adverts for what you can do with engineering and your enjoyment and your success in your career. But do you think the pathways that you've kind of highlighted are accessible to young people who don't really know what they're doing, perhaps struggling a bit in school? Do you have colleagues who have taken other routes into engineering? I don't know who wants to pick up that first, but it's about, yeah, if you don't really know what you're doing and you're not you're not doing your science A levels, do you think you can, is this still a pathway that's accessible to you? Who wants to go? Ross, what about you? Do you encounter people who've taken different routes into engineering?
Yeah, so I actually work with a couple of people that have taken different routes to engineering. One of my colleagues, who is now a robotics engineer, has just completed a university degree after being an electrician's apprentice.
Right, okay.
So he was going to be a Sparky and then found it wasn't for him, went off to university, did his degree, and now he's a marine robotics technologist just like me.
Yeah. That's great. Yeah. So you can take different pathways and still end up working in these fields. Now, we've only got a minute or so left of our session time before we're going over to look at careers that you can do with maths. So in our final minute, panellists, if I could just come to you all and just give a bit of advice to the young people who are watching, try and encapsulate any advice that you wish you had had, perhaps when you were back in secondary school. Who wants to go first? Sehar. Do you want to?
Yeah, of course. I guess I would say, it's completely okay if you don't know what you want to do. I mean, even when I applied to my job, I was still like, oh, I don't know. Is this the right company? Is this the right place? But kind of, I guess the only way that you're going to figure it out is if you just get all the experience you can. Just apply to in school, if you get the opportunity to do engineering programs, go ahead and do it. I know my uni do a lot. And just if there's specific work experience, or even just my part-time jobs taught me that I like working with people. So working in Subway, that taught me that I like working in people. I guess just trying out everything you can.
Yeah, that's
and
great.
You figure it out.
That's great advice. Thank you so much for taking part today. Ben, any advice for the younger generation?
Yeah, I think I heard someone in the last session say basically exactly the same thing as what I'm going to say, which is just sort of keep doing what you enjoy doing. I didn't really have a goal of becoming an engineer and ending up in chemical engineering department, but I just sort of kept doing what I felt mattered to me and what I interested me, and that kind of built the steps of the sort of journey that I've taken. So I think my advice would just be do what you enjoy most and sort of figure the rest out as you go.
Yeah, I think that is great advice, and certainly something that I've also done throughout my career. So Ben, just a final word from you. Not Ben, Ross. Sorry.
I couldn't agree with everybody else more. Find the things you enjoy and do them. It's the best thing you can ever do.
Fantastic. Well, thank you all so much. Thank you for joining us for Protecting with Engineering, part of POP24. We're now going to hand over to the team who are thinking about protecting with maths. Bye for now.